Unsiloed podcast is produced by University FM, elevating the stories of your institution.
Welcome to Unsiloed. This is Greg LeBlanc, and I'm here today with Leslie Valiant, who is a professor of computer science and applied math at Harvard University, also the author of a couple of books. There's this book, Circuits of the Mind, which I don't have with me, but then we have the most recent book, which is called The Importance of Being Educable, a new theory of human uniqueness, which was preceded, I guess, about almost over a decade ago by this one, probably approximately correct. Nature's Algorithms for Learning and Prospering in a Complex World. Welcome, Leslie.
Thanks very much for having me.
So I have to say, I really enjoyed this latest book of yours because it covers a lot of issues that I've been focused on most recently, having to do with artificial intelligence and so forth. But I think it covers a topic which is much broader, which is what it means to be fully human and what it means to be a good learner. And also, for me as an educator, what it means to be an educator. And I think the way you started off is you were thinking about, what it is that makes humans different from almost all other animals and objects. And I think the recent focus has been on intelligence, right? Our intelligence. And you make a distinction between intelligence and educability. And I think perhaps you suggest that our obsession with machine learning and artificial intelligence might need to be supplemented with an obsession on machine educability and artificial educability. So I guess maybe the place to start is, what is it that people are missing when they think about artificial intelligence or intelligence more generally, regardless of whether it's carbon-based or silicon-based?
Well, I think the difficulty is that we don't really know what the word intelligence is, and we've been using it for more than a century, and using it without, having any knowledge of what it means. So I don't think it's been very useful, for example, in the study of artificial intelligence. So I think in the context of IQ tests, I think it arose in the early 1900s in connection with attempted definitions of intelligence in terms of people finding correlations between abilities of children to do various subjects at school. And they hypothesized that the children who were good at many subjects had something, and they hypothesized that what they had, this something, was this intelligence. But that's not a definition of what intelligence is. So they didn't provide specification of how you recognize someone who's intelligent. It's a purely statistical notion. It's like a correlation, so I think to understand what one is doing, one has to have a definition of what one is trying to achieve. And in some sense, the successes of AI have been along those lines. So machine learning was something which was defined in terms of what you wanted to achieve. So you had examples of things, and you wanted to achieve a prediction of new examples with high confidence, and people managed to implement this, and this became the kind of the backbone of AI. So I think so in understanding humans, I think this is the way forward. We should understand understand what kind of things we're good at, what we do, what our functions are. And saying someone is intelligent is almost like name calling.
Well, it seems like all the stuff that we have learned as a result of our attempts to develop artificial intelligence have taught us a lot more about human intelligence. I mean, it seems to be like there's this flow back and forth between what we might think of as the cognitive sciences and what we might think of as computer science. And I think you made the argument, and I guess you're following from Herb Simon in this, that computer science is really the domain of information processing. And so, I mean, maybe this is like an imperialistic view of computer science, but the idea that computer science as the study of computation should be thought of as the study of, I guess, intelligence and maybe even education more broadly.
Yes, I think this goes back to Alan Turing. So the idea that there's just kind of one kind of computation, with all these various phenomena we see in humans and animals of various tasks we were able to do to teach each other, to learn, process information, analyze information are all aspects of the same thing as computation. And physical computers do this, and human brains do this, and other things about how to do this. So there's basically one thing to study.
Well, I mean, when we think about machine learning models, I mean, we're thinking about inference and prediction, right? And I mean, can you build a civilization? I mean, you talk about educability as the civilization enabler. I mean, could we imagine a world where the current machine learning models were able to build civilizations in ways that, crows and horses couldn't?
Well, no, because currently machine learning AI models are concentrated on one aspect of what I call educability. So basically, my model of educability has three aspects. One is learning from examples, which is exactly what current AI is good at and does fantastically. The second is some kind of training or reasoning on things we've learned, and current AI is trying to do that now. And the third thing is being able to take instruction, where people to give you explicitly their beliefs and their theories, and you don't have to learn that by yourself from examples, but you can just take advantage of other people's experience and incorporate all these things. So what we're good at is incorporating these three things of learning from experience, doing reasoning on what we've learned from experience and applying it, and also taking instruction so we can take advantage of other people's experience. So I think these are well-defined notions which you can express in computing terms. There's no reason why computers shouldn't be able to do all this well. At the moment, what they focus on is kind of essentially a little more than 1/3 of this, and they do that very well.
But when we add in some programmatic instruction to our machine learning models, I mean, isn't that a way of effectively replicating all these different aspects of educability?
Well, yes, but it's hard to do. How to put the three things together so they work. So the fact that humans take so long to be educated is one aspect of this. That that is not, one shouldn't view educability or the human cognitive capability as being kind of a single object, and we're trying to do the best version of it. I mean, there are kind of many versions of it which depend very much on how we've our experiences, how we've been educated, and we all diverge and become good at different things. So I think when we get AI systems to approach this kind of quality, then I think what we'll find is some AI system which is very good at one kind of thing. It's been well educated in one direction, just like humans. If someone is impressive, they're usually impressive at one thing they've spent some time on trying to be good at. And I think it's not finding one secret key to what's called AGI. I don't think that's what it's about.
Well, maybe we can walk through some of the ingredients that go into educability, right? Because clearly, animals, they already have some of these ingredients, right?
Indeed.
AI systems have some of these ingredients, and even non-animate things like evolution. We could talk about evolution as sort of a system of learning in some way, but it lacks this educability feature. So maybe we start with just the simplest, and you start off the book by thinking about, like snails, like even, bacteria have the capacity, I guess, to sort of learn things, right?
Yes, so learning from experience, learning from examples. I mean, that goes back, I think, a very long way in evolution. That you wouldn't survive for very long as a creature if you didn't adapt to what you saw, if you didn't adapt to where the food was or where the dangers were. So simple versions of that, they're probably most ancient in evolution, and that's what, of course, current AI systems can do on a grand scale. But also even the second aspect of chaining together what you've learned in different contexts, some kind of reasoning. I mean, that's also, I think, other species can do that also. That you can behave well in new circumstances because somehow you've pulled together, you've added together two different beliefs you have, which you've learned maybe in different contexts and which are okay to add together.
Right. So if we think about just the basic deep learning model, right, where you have all this labeled training data and you feed it into a model, and you get some kind of classifier, right? I mean, they can still sort of do classifications on things that they've never seen before, right? Sort of out of sample stuff, right? And yet there are going to be certain situations where the model is going to be stumped. And so what is it that's different about what the animals are capable of doing?
Okay, so what current AI models do well, and which is very well understood theoretically and by experience, is that if you feed examples from one source kind of randomly, and you train your neural net, then you can behave well on some new example from the same distribution, from the same source. So if instead you give a totally new kind of example to this thing, then all bets are off, because in principle you've learned something in the world, and if the world is totally changed, then nothing useful. But in between there are cases where you maybe learn from two different contexts, and you are faced with a new problem which you haven't been trained on. Okay, so also one example I use is if someone asks you, did Aristotle own a cell phone? Then most people can answer that, and it's not because we've been trained on many examples of Greek philosophers with domestic appliances, but we can somehow chain together different things we've learned. So this chaining together of things we've learned in different contexts is an important aspect of educability. And I think mammals can also do this to a reasonable extent.
Mm-hmm. Well, I mean, you make a distinction between formal logic and robust logic. And I was wondering if you could talk about that, because, I hadn't really thought about anything like this until I really started studying data science and machine learning.
Yeah. So I think that's a fascinating story, because obviously we think that reasoning is very important, and it's almost for some people it defines what humans do, what civilization is. But in fact, reasoning is almost as bad as intelligence in that fact that we haven't actually defined it. That there isn't a unique way of reasoning. And so in this educability framework, one doesn't define a unique way of reasoning. You define more a generic way of chaining together things. And then we learn different methods of reasoning. So in school, we may learn arithmetic, which we never, which was invented by some human at some point. And it's a new method of reasoning, and we can apply these rules of inference, which arithmetic tells us, for our general reasoning mechanism. So the methods of experimental science. Again, it's rules of inference which aren't obvious. You have to be taught. When you're taught it, you can use it. So I think the interesting thing here is that besides having the hardware to do this chaining, the different kinds of reasoning we do, we're educated in. And, in some sense, human civilization advances because people discover new methods of reasoning which weren't known before. So, so in mathematics, we do probabilistic reasoning. We assign probabilities to things. And surprisingly, this has only been around for a few centuries, although people could have thought about it earlier. So I think this is, I think, an example of the fact that we've got this general capability for educability, but its fruits develop by the fact that successive generations have discovered new ways of using it more powerfully. So I think that's basically with essentially the same intellectual hardware, which we may have had for hundreds of thousands of years since the beginning of our species. Because of the extra knowledge people have discovered, we can use this much better and better.
Yeah, but I mean, you talk about modularity, right? So the idea that we can learn in these distinct modules and then at some point kind of stitch it all together.
Yes. So the circumstances under which we can stitch together things we've learned in different circumstances. The circumstances in which that's valid. One circumstance in which that's valid is if these domains are kind of independent, so that when you argue that if Aristotle couldn't possibly have had a cell phone, use facts about when this thing was invented, that something didn't exist before it was invented. Use facts which are true independently of each other. So I think that happens to be a fact of our world which is useful, that there's much modularity.
And so this is what you refer to as integrated learning system. Sort of what exactly is an integrated learning system?
Well, it's basically the combination of learning by example and being able to chain together what you've learned in this way. So if the world is modular, then that's one circumstance in which this is very effective.
Right. So in other words, you can make predictions about something that you have never seen before.
Right. So it's things which you couldn't have done just from learning from examples, because the example doesn't resemble anything which you've seen before.
Yeah, I mean, one aspect of humans is that we can learn from others, right? We don't have to learn from experience. But I mean, other animals can also learn from others. And I think you made a distinction between sort of training and education. I mean, what's the difference there?
Okay, so the point I make is that training, for me, is when you kind of get someone to be able to do a task where you foresee exactly what they have to do. So you may train someone to do some particular move in a sport, you know exactly what you're training them for. But education is different in that you do something and you can't foresee how this knowledge is going to be used. So somehow what you teach hopefully is very general, and you expect that the learner will be able to chain together this maybe with other knowledge in the future, 20 years later, in ways which can't be foreseen. So certainly in science education, you hope that your students 20 years later will discover something which certainly you can't foresee. So I think that's okay. So that's the difference there.
Well, I mean, when you see, so, we have these examples of these animals, right, who are, cracking nuts and maybe there's another animal that's kind of watching them do it. And they might even, I don't know, make some kind of gesture to try to, convey what it is that they're doing. I mean, should we think of that as training that they're doing?
Yeah. Okay. So I think that's a separate distinction. So okay. So that's a good question. So many people study animal behavior talk about social learning, which is that learning from others, and not just from your parents, but maybe from others in your group. But I think what I'm talking about, being able to take instruction, is much more general than that. That we can take instruction in the sense that we can execute very complicated procedures which someone has just told us. Someone gives you a formula for doing something or a procedure, and you can just take it in as if you've learned it yourself from experience. So the point isn't so much whether you've learned it from another individual, because when people talk about social learning, they're not implying somehow that this is somehow more complex than learning from experience. So it's just that you're doing social learning from another member of your species, but maybe they're just pointing out to you interesting examples from which are good things to learn from. But this is still learning from examples, but this helpful individual is telling you which are good examples to learn from. Whereas what I'm talking about, taking instruction, is someone not just giving you examples, but like if you study physics, someone teaches you a formula, how you predict how long it'll take some object to get around the world. So this, so Isaac Newton may have learned this from observation, but we don't have to, because we can use his formula. So I think this is a different notion. So I think taking instruction, being able to execute complicated things which another person has given us. So again, to some extent, you can find it in the animal kingdom. Nothing by itself is totally unique to humans. So in the animal kingdom, people do experiments where a human demonstrates some complicated contraption and some complicated physical way, sequence of actions. You have to do some contraption to get a result. And yeah, so some animals can do some of this. But we can clearly do it with enormous facility. That people sit in a classroom for a semester and learn an incredible amount of stuff in this manner. This is very classical kind of education.
Well, I mean, it's kind of strange because we've had the same hardware, I guess, and we've had the same genes for a really long time. But the kind of civilization that we see around us, I mean, this is a relatively recent thing, and it seems to be becoming more complex in an almost exponential way. And so, does that mean, I mean, have we always been as educable now as have we always been as educable? I mean, what's different? I mean, what I found fascinating is you referenced this example of, Luria, who went in to interview these kind of, I guess, less, quote, civilized folks, and they thought very differently than we do. I mean, they really emphasized example. And what I also found fascinating was that when you tried to offer up hypotheticals, if you did it in a fictional environment, right, people thought very differently, right, and were more willing, I guess, to engage these abstractions than when you tried to talk about something in the real world where they really wanted the experience to back it up.
Yes, so our behavior depends very much on what we've learned, our background. Also depends very much on exactly how the question is posed to us. So it's complicated. But as to your main question, yes, I suppose no one is sure. So in writing the book, I found out that, to my surprise, that apparently there's no evidence of any mutation, any genetic mutation having been adopted by the whole human population, having swept the population since the existence of our species. No one has found that yet. So the evidence is, there could be various other ways in which our genetic makeup could have changed, but it's quite possible that at the beginning of our species, about 300,000 years ago, we've been essentially the same. We've had the same capability. I mean, I think that's kind of my default assumption. But it's just that if you have this capability, you can't use it very well. If no one teaches you anything interesting, there's nothing interesting discovered yet, then you can't. No one has told you anything interesting. But once people start discovering interesting things like science, then it's like a rolling snowball. You can discover more things, spread it around the population even faster, and so knowledge and discovery can explode. And certainly technological things like books and more recently the internet, speeds things up incredibly.
But I mean, if we use the analogy in machine learning, I mean, machine learning has gotten better and better, but for two reasons, right? I mean, one is that computational capacity has gotten better, and the other is because, we have a whole lot more data that we can throw at it. So, I mean, are humans better because we have kind of more training data available, or because we have, better programmatic instructions installed, or is it because, we've simply learned how to reason in different ways? I mean, what is it that makes us, I guess, better in some way than we would have been 300,000 years ago?
Well, I think it's because we've discovered things which we've passed on to successive generations. So with this capability, it's individually in one location, it's difficult to discover something new, maybe discover something new, but it's hard to pass it on to many other people because you've got a very small community. So it just took a long time. So for various reasons, we finished up living in larger communities, maybe 10,000 years ago. And maybe that helped a lot in pooling information and newly discovered knowledge. But okay, so I think that if our hardware has stayed the same. The only thing that could be different is kind of our culture, what we've discovered, what we know, and what we pass on to successive generations. And also, we may have been better at passing things on. So language may be much better now than it was at the beginning.
Yeah, I mean, you pointed out how there are certain types of reasoning that are of relatively recent vintage. I mean, if you just think about like formal probability theory, right, or the scientific method, these things have opened up an enormously different trajectory of learning. But it is kind of puzzling, right, why it kind of took so long, right, for us to stumble on these rules, right, these ways of reasoning.
Yeah, it's a fair question. So I don't think anyone's got a totally good answer. I think it's plausible that once you start on this road, like certainly once you get the scientific revolution, 300 years ago, then it's clear that you can go on. But why it started in fits and starts? So some things may have been discovered in some parts of the world and just forgotten. So there were civilizations and which just vanished into the jungle. It took so long, it's hard to explain. But again, it could be that humans were very small in number. They lived in a very distributed way in small groups. They may have had more problems to feed themselves and to escape dangerous animals, to spend too much time thinking the imponderable. So there may have been lots of practical reasons why it took a long time.
I mean, are we sort of chaining? Do we have more complex and extended chains of reasoning than we did in the past? I mean, is that what the written word enables? Is that what having the capacity to store more information in our cultural repositories, is that sort of allowing for more sophisticated embedding and stacking of these different chains of inference and reasoning?
Well, it may be that the individual capacity hasn't changed very much, but certainly we use the fact that we can offload to some outside device like a piece of paper or a computer a lot of knowledge, and when we do our training, we only have to keep in our mind a very small part of this. So we're certainly helped by technology, whether it's scratching on stones or writing on paper or using computers. So we do have some outside help to our physical devices, and surely that probably helps. So if you're just sitting by yourself on the beach, even if there are 5 of you, it's probably difficult to make too much progress.
Now, I think a lot of people are asking the question of whether, LLMs are capable of reasoning. In fact, I mean, the most recent models actually advertise their capacity for reasoning. I mean, is it truly reasoning that they're doing when we sort of add reasoning to the models?
It's a good question. As I said, there's the unique definition of what reasoning is. I mean, they do chain together things, and they probably find like patterns of reasoning. They can do patterns of reasoning which they found in a lot of the data they're trained on. So I don't think it's very generic reasoning. So, for example, they can do reasoning quite well on some math problems if they're trained on some large number of math problems of a similar kind. So one shouldn't reject it as not being reasoning, but it's a kind of restricted reasoning for which they're trained. Okay, so I think most of what we see, which is still impressive, is that they can pick up patterns of reasoning from the data they're trained on and do something useful. So we shouldn't reject it, but I don't think it's how it's done currently. I don't think it solves the generic problem of how to incorporate generic training. But they can get there. They'll get there eventually.
Well, what's missing, though? What would it take for us to be able to describe the machine learning models as comparable to what humans are doing that makes humans unique?
Well, okay, so actually in the book you refer to, I try to point to this. It's kind of, in the book it's described rather non-technically, but if you follow through to the appendice, to the note at the end, there's a technical proposal there. So yeah, so it's no mystery of what one may want to do if one wants to train on knowledge which is learned. So the main feature of learned knowledge is that it's kind of uncertain. So knowledge which is learned from experience is kind of uncertain. When you train it, I mean, the result gets even more uncertain. So how do you give some meaning to it? But you can. Um, but if you implement this on a computer, then it probably takes even more resources than what they do at the moment. You have to be more expensive computationally. So people try to use shortcuts, and in some sense, that's what's happening now. It's certain shortcuts which the systems are using now, and they do useful things. But
well, I mean, you mentioned a couple of things. You talk about lifelong learning. You have concerns about spurious correlation, adversarial examples, and the lack of explainability. I mean, these are things that a lot of people in the field are always talking about. I mean, are these ultimately things that are solvable?
Well, these are all different things, and I think they have got different answers. So explainability is a controversial notion. So my my take on that is that one could do more. One could have the systems more explainable, but one would do it with respect to some kind of what I call domain of discourse. So some set of notions. You have to tell what set of notions you want something to be explained in terms of. So that you can do, but it's not that you can. If you learn from experience, then even humans aren't very good at explaining why they're going to do something. If you have to explain why you're going to prefer restaurant X to restaurant Y, well, you may try a few attempts, but if I drill down in the end, you say, I don't know why. I just like it more. So explainability is by itself isn't something which is absolute. Okay, so I think in human behavior, at a high level, we can explain things. So probably a doctor who gives you a diagnosis can explain to you to some level what the components of the decision are. But beyond a certain point, while the doctors in the end decided that it's X rather than Y, at some point they'd also give up saying it's some sort of intuition. So some of the issues which are raised as very big questions for AI systems, we just have to think more carefully about, that what is the problem, what's achievable, and what's just fictitious and unrealistic.
You're saying all of these things that, when you push humans, they also come up short to some degree?
Yes. So explainability in humans has its limits, sure. So if whatever you tell me, I keep asking you why, at some point you'll give up.
I mean, you had some thoughts on educability as, a characteristic of people, right? That might differ across individuals, right? In the same way that intelligence differs across individuals. And I think you also suggested that, we may want to think about cultivating this characteristic or trait and honing it and helping people to, become more educable. I mean, what would that look like? What does that mean?
So educability, in my sense, is a kind of a new notion. So I don't know what the result of future research will be.
Maybe you'll devise a diagnostic, right?
Yeah, but I'm saying surely what I'm saying is our main human characteristic is this educability. A, B, we spend these enormous resources on educating people, so we go to school for 10, 15 years. So surely if we could do this education slightly better, that would be surely good. If we could define better what we want to achieve and do it more efficiently. So that's what I think we should spend more resources on understanding our educability better. So seeing whether we could have methods which not just increase our knowledge but increase our educability means that we must have some method of measuring. So if you go to a course on increasing your educability, presumably you want to know that at the end of it you're better at it than you were before. So we have to be able to measure it. So I think that's I don't think the purpose of that wouldn't be to sort people out according to the level of educability. I wouldn't want that to be the purpose, but for the kind of societal goal of trying to focus people's attention on increasing our educability as being a goal of education, we may have to go through measuring individual educability.
Yeah, I mean, I go through and tell my students, particularly my MBA students, that the thing that I want them to get out of the MBA program is not so much knowledge about, financial statements and quantitative methods and so forth, but, I want them to be able to process information better. I want them to be able to, synthesize observations better. I want them to have the capacity to download things from the abstract, from academic content and wed it to their experiences. And, these things are very, very high level and they're almost impossible to measure, right? So as an instructor, I struggle because I say, I want you to develop these skills and aptitudes. And then ultimately we just test them on, whether they can do a two-sided t-test, so I mean, and then if we focus on those test results, then we're ultimately going to, I guess, spend less time on the cultivation of these skills that we really value.
Yes, I agree with all that. So I'm also in the education business, but I'm shocked by the idea how little we know about how effective our teaching is. So you say you got your goals, but do you know how effective it is? Do you know
Right,
there's a way of doing twice as well in some dimension, and so in some sense, I've been in education for a long time. All these new ideas about education fly by my screen every day, but I know it's hard to tell which is good, which is bad. There are very many of them. And I think there are very few, there's very little knowledge about retention. So, we teach, but what's retained after 20 years, that's very hard to investigate. So I think this, how effective education is it seems to be a big question, which, it worries, it didn't worry me. I just teach the way I like and no one interferes with me. But I think we should be worried. I mean, there could be incredible societal benefits if we could understand education better and think about it a bit more, let's say, scientifically.
But in the book, you also talk about the potential division of labor, right, between machine intelligence and human intelligence, for lack of better words. And, you conjecture that there will always be perhaps a potential division of labor. And when you were talking about the things that make up educability or the characteristics that an individual has that kind of strike you as correlating with this educability, those seem to be the things that are not really done well by machine intelligence, right? So, you talk about common sense, right? And so forth. I mean, is it increasingly important that this thing, which is uniquely human, be the thing that we teach? I mean, pattern recognition and, memorizing training data and then like regurgitating and that sort of thing. I mean, that was at the foundation of education in the past. It seems like we probably shouldn't waste as much time on that in the current educational environment.
Right. So educability, I'm saying, is unique for humans as compared to other species. But I don't think it's unique as compared to machines, because eventually we will make machines which are educable, I think. So as far as education is, so I agree with your last comments for sure. But I think the point I'd make is that so the aspect of educability, first are learning from experience. The second one is kind of using your experience, applying it to cases, using reasoning. The third one is taking instruction in the classical sense. So I think educational philosophers, I think, discuss these 3 points separately. So as you say, the last point, just taking information by instruction, by itself is a very drab way of educating people, especially if a lot of information is available. So I do think that the educability is the mix of these three things. And in that sense, it's not so far from kind of some consensus view of educational philosophers who usually tend to argue about the three aspects, one against the other. But I think I'm trying to integrate the three. So certainly, I think we should think more about what education should be, how it's most effective. And with this notion of educability, I'm trying to tease apart the different aspects of it and discuss them in a way which is kind of concrete. But I think the main thing is that we should we don't know too much about this. education business, in my view. Although, millions of people are in this business and do it well and work very hard. But, I, being in the business, don't think that we know too much about how we should be doing it.
Well, I mean, is the philosophy of just throwing more and more and more data at these machine learning models, I mean, is that ultimately incomplete? I mean, what would we need to do in addition to just throwing tons and tons and tons of data at these models?
Well, to make machines educable.
Yeah.
Well, okay, so this corresponds to giving people more and more experiences. I'm saying, in addition, we have to put in new methods of reasoning, because reasoning isn't a unique one kind of reasoning. So you have to decide what method of reasoning to put into your machine. I mean, the machine may be able to pick up some methods of reasoning from the data. So if the data shows people reasoning a certain way, but still, there's decisions to make, and it also depends on what if you give it if it learns by instruction, you have to decide what to do the instruction. So the simplest way of looking at it is that we've got enough problems deciding how to educate humans, right? So human education has this incredible variety. In a college, you've got these thousands of courses. There's no way of deciding which is the best. And for machines, again, we've got the same choices to make. There's no unique best way. There are options, there are choices. We have to think about it. And there's no single goal.
Well, could we expect them to develop their own forms of reasoning the way we did as humans, right? Could they start scaffolding new types of reasoning on tops of whatever reasoning we instruct them with?
Well, in principle, you could wait for them to discover new methods of reasoning, but again, we think in education. I mean, universities employ people like you and me, and what we spend a lot of time doing is to decide what's worth teaching, right, and what we shouldn't teach. And I'm saying with if you want to educate a computer, someone will have to make the same decisions. Just pouring in all the information won't do it.
But would we use the same forms of instruction? I mean, like I teach using the case method, right? I mean, would it make sense to sit down with our foundation models and start, using case method and having debates and dialogue? I mean, do we need a different way of instructing?
Well, I don't know, but I think as with humans, the different approaches to teaching, case method is one. And probably there's no consensus on what the best method is, right? Not everyone uses the case method for everything. And do we really understand, say, under what circumstances you should use the case method and when you shouldn't? I'm saying these are kind of issues which I think there's room for further understanding.
And presumably at some point, maybe these machines will start teaching each other, right? Maybe they'll get good at teaching as well as learning.
Possibly, sure, yes. I think Alan Turing, a long time ago, already said that it's hard to find any human capability which we won't be able to teach, make machines to be able to do. So that's essentially correct. But for each capability, we may have to think very carefully about how to do it. And furthermore, we have to think very carefully about what capability to have machines have. So there's no panacea, because all the problems we have in deciding how to educate humans, we'll also have in deciding how to educate machines.
And presumably we also are faced with the same measurement problem, right? So if we can't measure educability in humans, then it's kind of hard to measure the extent to which we're making progress in educability of machine intelligence, right?
Right. But I'm saying for measuring educability in humans, there's a way to start. So I do make some proposals in the book how one may start. So that's not a lost cause, because as long as educability is defined as some particular capability, then you can measure whether you're better or not than you were before.
Well, I mean, it sounds like you are proposing a new research agenda. Um, and this new research agenda sounds very interdisciplinary. You point out that education is kind of an academic field that is somewhat marginal, right? It's not something you can't major in it, and it doesn't really tackle the key questions that you're talking about. And so, what would that new research agenda look like? I mean, would it be computer scientists who would be taking the lead here?
Well, no, I think it would be very interdisciplinary, as you say. Um, so if you're asking practical questions of how one would go about it, actually, I do think about the beginnings of computer science, say 60 years ago in academia, when people didn't know what computer science was going to be. But people who were teaching courses which vaguely sounded like relevant, they got together and started teaching something. And this whole very rich field evolved from that. So I think in practice, if we're talking about what would happen at an existing university, I think you need people to come together who've got relevant interests from different departments. And some of the obvious ones, maybe like obviously education, schools, psychology, I think also computer science. And, put on courses which kind of adhere to this theme of some sort of science of education. Of course, science of education isn't a new idea, but I think computer science does give it a new flavor. I think it does give it new impetus. But obviously, computer science cannot do this by itself. But there are lots of people interested in around campuses and in AI, education, psychology, behavior. So I think this isn't a hopeless task to actually do on a campus.
Now, I think you also mentioned that educability, while a strength of humans, can also be kind of a weakness of humans, right? And so if there isn't some mechanism for keeping error in check, right? If you're not making predictions about the world where there's direct consequences, then you could sustain these very complex systems of belief that are potentially harmful and potentially, false or fictional. I mean, how does one balance that trade-off, right? How can one promote educability without also promoting, I guess, vulnerability to these complex fictions?
Yes, well, so I'm saying that we already have these incredible capabilities for processing information, for absorbing information, processing it, applying it, running with it, and this capability somehow exceeds our ability to evaluate information. So if someone gives us a theory, we can't. So someone gives us some story about what happened on the other side of the world yesterday, we can't rush over to check it out. We either believe it or we don't believe it. So we find it very hard to evaluate everything we hear. There's no foolproof way of doing it. Being aware of it as a weakness, I think, is useful. So that's what I'm emphasizing. That is, it's not just the problem of bad guys telling us lies. That's a problem. But if we're aware of our weaknesses, but I mean, there are people who study propaganda. There are people who study how propaganda works, what kind of things people find, how you can fool people into believing things which are implausible. So it was even from the time of ancient Greeks, they studied how to persuade people by using various kinds of arguments. It's kind of propaganda. So I think we could study how to make ourselves more resilient to propaganda. And again, some people are doing this and have been doing it, but it may be more important now. So people emphasize the dangers of fake things on the internet. So this may be an impetus. So we've got many more false inputs which we're subject to now. So this is an impetus to studying our weaknesses, but I think our weaknesses are more general. So even by traditional means, we can easily fooled into thinking, into believing some strange theory. But I think it's a very important area to think about.
Well, I have a lot of people talking about having agents, artificially intelligent agents as employees. Should we be thinking about artificially intelligent agents as as students as well? I mean, are we going to need to set up universities for our AI agents, right? Are we going to have to think seriously about creating environments of education for these artificial intelligent agents?
Well, I think in some sense, we're in making one of these, we're already doing it. And if you're saying that these things will let loose in the world and they'll be running around like humans, so I think that I don't quite see that world. So how much control to give one of these AI agents is a serious question. It's not just a question of their capabilities, but what will they be? What power do you give them? So how much these AI agents will be free running? I'm not sure. But certainly, I mean, educating agents is the same question of how you make them.
Yeah. Well, I mean, you said at one point in the book that there are people who are afraid of these super intelligent actors. And you said maybe we should be afraid, if anything, of super educable actors.
Yeah, okay. So actually, I may have said super educated ones who've already been trained with incredible knowledge.
Mm-hmm.
So I think these old arguments which were based on the notion of intelligence, that this is a one-dimensional world where you can make more and more intelligent machines, and once they get more intelligent than us, then the world falls apart. So I don't believe in that. I think that's a bit fallacious. It's not a one-dimensional thing, partly because we can't define intelligence. But I think this notion of educability, I think, gives one some reference point of how to discuss these issues, which I think just using the word intelligence and smarter doesn't tell us what to do.
Well, what I find fascinating is that there are these studies that show that if you simply ask an LLM a question, you'll get an answer, but the quality of that answer will not be as good as if you create a bunch of agents and have them engage in a debate and a dialogue, right? I mean, this to me is fascinating, but it has analogies to what you're describing, right? Where you use these different classifiers and you have them work together, and you ultimately can get a system which is much more robust.
Right. So I think one basic LLM basically is just a predictor of the next syllable. Now, some of them do try to chain together some things, but if you have several of them, then in the end, what they do in their conversation is to chain together what they variously posit and so kind of analyze the situation a bit better. So it's kind of another stage of reasoning, I think, which they do together better than a single one can do.
Well, Leslie, this book, Importance of Being Educable, I mean, I certainly found this to be a fascinating book, not just because of what's new, but also the material that you review from your earlier work. So fascinating. Hope everybody goes out and gets it, and hope we can chat again soon. Thanks so much.
Okay, well, thanks very much for having invited me. Thank you.
Unsiloed podcast is produced by University FM, elevating the stories of your institution.